Alright, so we're just going to continue on working with linear relations a little bit more. You would have done some of this last year in grade 9, and what we're just trying to do here before we really dive into the course, to the grade 10 course, just review how to go from describe situations, word problems, into expressions or equations, okay? Because we're going to run into a lot of word problems both in this unit and throughout the rest of the year, and being able to create those equations that we can work with is a key starting point there. So just as a bit of review here, in general, if you have word problems, and if there's anything unknown that we're trying to find, we always have to define them with a let statement. And then we have to try and take some keywords that are in that word problem, in that description of the situation, and try and convert them into some sort of algebraic symbol so we can create an equation. So if you look on the left side of this slide here, we have a whole bunch of keywords that you see a lot inside word problems. And what you have over here in this chart on the right here is a bunch of different symbols they could translate to. So what I want you to do first here on your own, so pause the video and give it a go when I say go, is to try and sort these keywords into the chart where you think they go. So for example, if you look at the word sum, well, sum means you're adding numbers together, so that would fit here under add. Okay, so try and place all the rest of the keywords here in the chart and push play and ready to go through them together. Okay, so you can take a look at what I got here for the chart. So the keywords sum, more than, plus, and increased by all fit in under add. Reduced by, difference, and less than all fit under subtract. For multiply, we have of, times, twice, and half. So I'll talk about why half appears twice in multiply and divide in a second. And for equals, the only word is. Now the reason I put half in two different sections here of the chart is because you can, if say a number is half of another, that means you can multiply it by a half, but it also means you could be dividing it by 2. They mean the exact same thing. So if you see that a number is half another, for example, in a word problem, you could apply that 2 different potential operations to that. Okay, so hopefully that was a nice little bit of review for you. And now what we're going to try and do is try and put this into practice here. So I'm going to give you some sentences here, and I want you to try and turn them into algebraic expressions. So there's going to be some unknown number that we're going to call n. And for example, when I see 7 less than twice a number, I want you to try and put that into an expression. Okay, so I'll do the first one with you. So the first one says 7 less than twice a number. So remember, we let n represent the number here. So so it looks like here I have twice a number. So if the number is n, twice the number will be 2n, and it says here it's 7 less than that. So it's going to be 2n minus 7. Okay, we're just turning that into an expression. And this isn't really an equation you can solve for, it's just an expression. But again, we're just translating from sentences into algebra. So I'd like you to try the next two on your own. Take a minute to do those and push play and see the answers. Okay, so in B, 20% of a number, remember when you're dealing with percentage, you have to turn to a decimal, so you divide by 100, so 20% is 0.2. Okay, when you see the word of here, that means multiply. So 20% of a number is 20% or 0.2 times that number, which is n. Okay, and for C, we have 4 more than half a number. Well, half a number is either taking that number n and dividing it by 2, or multiplying it by a half like you have here. So you have half a number and 4 more than that, so it's n over 2 plus 4, or you can simply write it as half n plus 4. Two ways of approaching that one. These mean the exact same thing. Okay, so now let's take a look at some word problems. And so for each of these situations, we want to define variables and write an equation. So in the first case, Rebecca has a day job and an evening job, and she works a total of 45 hours. Okay, so in this case, we actually have two different variables here. We have the hours worked at the day job and the hours worked at the evening job. So we need let statements for each of those. Okay, so I'm going to quickly write two let statements here. So I'm choosing D and E as a variable, so D representing the hours worked at the day job, E representing the hours that she works at her evening job. So we know she works a total of 45 hours, so that means the hours spent at her day job, which is D, okay, plus the hours spent at her evening job, which I called E, will be equal to the total that I have of 45 hours. So D plus E equals 45. Okay, so this would be an equation that would represent this situation. Now, again, we can't actually solve for D and E at this point because there's lots of different combinations that can make this true. She could work 40 hours at the day job, 5 hours at the evening job, or all 45 hours at a day job and no hours at the evening job. There's infinitely many answers here that we could use, but this would be an equation that would represent the information given. Okay, if we want to solve this, we would need more information. Okay, so with that in mind, I'd like you to try B on your own. So piggy bank contains $122.25 in quarters and toonies, and basically we're trying to find an equation representing the number of quarters and toonies. So that will be your two unknowns, number of quarters and number of toonies. So take a minute, write out let statements, define your variables, and write an equation that you think will represent this situation. Okay, and push play and ready to see the answer. Okay, so you can take a look. In this particular situation, I chose Q for the number of quarters and T for the number of toonies. You can choose whatever letters you want, but I chose these because it seemed to make sense. Now, a common mistake that you'll see here is I've seen a lot of students do this. They just say, okay, number of quarters plus number of toonies is 122.25, and that's not correct because this is the number of quarters, so like 3 quarters, number of toonies, let's say 5 toonies, but this is an actual dollar amount here. Okay, this is an actual value, so we can't have the numbers of coins that you have adding up to a value. You have to incorporate the value of those coins in some way as well. Okay, so you know that each quarter is worth 25 cents, so 0.25. You know that each toonie is worth $2, so we incorporate that. So the total value of the quarters plus the total value of the toonies is $122.25. Okay, I just noticed I have a few typos here as well. There we go. Just fix those. But yeah, this would be an equation that would represent this situation. All right. With these two situations, like I mentioned up here with Rebecca's day job, evening job, there's infinitely many answers here. If you're looking for one specific answer, if you're in a situation where there is only one answer, you would need a second equation to try and find that unknown. So if you have two unknown values, if you want to reach a single specific solution, you need two equations in order to solve. So here I have two different situations. I'm going to do the first one with you, but since there's more going on here, we can actually create two different equations for each situation. So let's take a look at A together. Okay, so it says the sum of two numbers is 56. 4 times the smaller number reduced by the larger number is 10. Determine the numbers. Okay, so this can be a very confusing description to read through. So if you need to read through it a couple of times, please do. But in the meantime, I'm just going to define my variables. Okay, so I chose A and B. So I chose A to represent the smaller number and B to represent the larger number. And now let's try and create some equations out of this. So let's take a look at the first part of this here and just do it piece by piece. So the first part here says the sum of the two numbers is 56. Okay, well that one's not too bad. So the sum of two numbers means I'm adding the two numbers together. So I'm going to have A plus B. Okay, so I'm adding the two numbers. The sum of these two numbers is equals 56. Okay, so that first little sentence right there gives me an equation right there. The sum of two numbers is 56, which means A plus B equals 56. Okay, all of a sudden now we have one equation, we have to create the second one. So now let's take a look at the second sentence, which is a bit trickier to figure out. It says 4 times a smaller number reduced by the larger number is 10. Okay, so let's just go through it piece by piece, see what we can get. So 4 times a smaller number, so just take a look at that first step here. 4 times a smaller number. Well, my smaller number is A. Okay, and 4 times that would just be 4A. So I have 4 times a smaller number reduced by the larger number. Reduced means subtracted, so subtract the larger number, which is B. And then we're told that that is 10. So 4A minus B is or equals 10. So that gives us a second possible equation we can use. So we have A plus B equals 56 from the first part, and then the second part altogether gives us 4A minus B equals 10. Okay. Now, as for actually solving for the answer for this now, that's something that we're going to be doing later on this unit, solving these types of situations. We have two equations with two unknowns. Today we're just focused on setting up the equations. Okay. So with that in mind, I'd like you to try and do the second one on your own before you look at the answer on here. So we're told the number of $20 bills is 5 more than 3 times the number of loonies. and there's $344 in total. And it asks how many loonies are there, but we still do have two unknowns, right? The number of loonies and the number of $20 bills. So you can start by defining your variables, try and create your equations, and push play when you're ready to go through the answer. Okay, so you can take a look at the answer here. And again, sometimes the trick is just taking it piece by piece and taking each piece and putting it into an equation form first. So the first sentence says the number of $20 bills is 5 more than 3 times the number of loonies. Well, the number of $20 bills I said was T, so I let T represent that down here. So T is equals 5 more than 3 times the number of loonies. So 5 more than means 5 plus, so plus 5 to something. And then 3 times the number of loonies. Well, the number of loonies I called L, so 3 times that will be 3L. So T equals 5 plus 3L, or you can write 3L plus 5. Okay, so that gives me my first equation there. My second equation says there's $344 in total. So using the total value of $344, I know each $20 bill is worth $20, and I know each loonie is worth $1. So in theory, I could have put in a 1 here to say it's 1L, but multiplying by 1 doesn't do anything, so I don't really need that. So $20 for each $20 bill, $1 for each loonie. Add those together will give you a total value of $344. So again, you get two equations there, and don't worry about solving them at this point. That will be something that we do in a later lesson. Okay, so let's move on. So here we have a situation. I'm giving you a graph here. So Jack and Jill rented a hall for their wedding. They go to the Chateau Laurier, and they are given a quote of $500 just to rent the room, and $65 per meal per person on top of that. And you have a graph of the situation right here. Okay, so just for more practice here, let's create an equation to model the cost of their wedding reception. So again, $500 up front, $65 per meal. I'll just copy that here so we have it handy. Okay, so define your variables. So what's the cost of their wedding going to depend on? And then try and create an equation. Okay, so for my variables, I let C represent the total cost in dollars, and N be the number of people. So their total cost, they have to pay $500 up front and $65 per meal. So that will mean they're paying $65, so 65N plus 500 to get their total cost. Okay, so you did some things like this back in grade 9, setting up equations for linear relations. Okay, and now that we have this equation, we can use it for a lot of things. Okay, so for starters, let's say they want to have 100 people attend their wedding reception. There's a couple ways we can go about it. So first off, we can use the graph that I gave you, and we can say, okay, for 100 people over here, we can go up to the graph and say, okay, looks like we're gonna, $100 is right around here, so what's the cost there? We can trace that over to the side and see that the cost is going to be $7,000. Okay, so very nicely from the graph, we can see that's going to be the cost to have 100 people. So that works perfectly well, but we also do have the equation as well. So let's say we want to use the equation. We have C equals 65N plus 500. Well, we know the number of people is going to be 100. So we're going to have 65, N is 100 people. Then we add 500 to that. So put that all together, 65 times 100 is 6,500. Plus 500. And it gives us the exact same answer of 7,000. Okay, now using the graph is nice if it's there and it's a nice clear graph, but if you don't have the graph handy, the equation will definitely work. Okay, so let's take a bit of a step further here and say, okay, now let's say they have a budget of $12,850 and they want to figure out how many people they can have. Well, okay, let's try and use the graph again. You're going to run into a bit of an issue here, okay, because $12,850 is not exactly a nice number on the graph here. We'd have to approximate, and that's never good enough. Have to approximate, especially when it comes to number of people. You want as many people going as possible. So in a situation like this, you absolutely have to use the equation. Okay, so here we're being given the cost of $12,850. Okay, and that's going to be 65N plus 500. And what we have to solve for is the number of people. Okay, so I'd like you to try the algebra to solve for N here, and push play to go through the answer together. Okay, so there's your answer there. To solve, I subtracted 500 from both sides of the equation to get the 65N by itself, then divided both sides of the equation by 65 to isolate for N. So that gave an answer of 190 people that they could have at their wedding. Okay, So that's it. That's all. There's homework there to practice, and that's it. See you later.